Hello, I am with the engine guru of Royal Enfield of the Sherpa 450. So, time to listen to the guru.
Okay, welcome to the engine tent, the Sherpa 450, our new engine. I'll show you a short introduction video now. Okay, so I'll go into some details now for you. So my name's Ben Adey and I'm the lead engineer on the Sherpa 450 engine, and I always have been. So I joined Royal Enfield in 2016, and in 2017 I completed the Royal Enfield Himalayan Odyssey, which is our flagship ride, and I completed that on the original Himalayan, and that's when I fell in love with the place and the people and the original Himalayan bike. So when I was given a team of fantastic engineers and a blank sheet of paper for the all-new Himalayan engine, it was like a dream come true for me. So I'll go into some details about the engine now. So what did the engine have to do? So as you've probably heard from other presentations about the all-new Himalayan, it had to remain accessible for new riders or riders stepping up from a smaller capacity vehicle, but it also had to be exciting for experienced riders. As you're also aware, our riders are evolving. They're taking on much bigger adventure rides into much harsher environments. So we needed to up the level of performance to cope with those globetrotter expeditions. So we needed a more capable engine, but it needed to retain that original Himalayan DNA that everyone loves and has got such a following. So I'll try and explain now how we've done that. So if we start with the original Himalayan DNA and what we've retained, it needed to retain the character and the accessibility. So what we've done on the engine is we've maintained a high inertia engine with a relatively low bore to stroke ratio. So that follows a similar architecture to the original Himalayan engine. So what that gives us is class-leading low-speed torque, and for the rider that gives instant acceleration whenever they request it. They don't have to wait for the engine to get to a high torque region, and it's quite a forgiving nature. So for the less experienced riders, maybe they may not be in the correct gear all the time. So even if they're not in the perfect gear, they can still make that overtake or climb up that rocky pass. Another area for character is the sound quality of the vehicle. So we've worked really hard on our sound quality of the exhaust and the intake, and also the mechanical refinement. So the original LS410 engine in the original Himalayan had a certain amount of mechanical noise, and we've tried really hard to refine that and reduce that, so you get the sound of the exhaust and the intake. To maintain the accessibility, even with the higher performance, we've now got rider modes on the vehicle, so they can alter throttle response and performance in the first 4 gears. So they may be used for a less experienced rider who might find stepping up onto this vehicle intimidating, and they can start to learn the vehicle that way. It may be used for if you're on off-road or a low friction surface, you can soften the throttle response, or it may just be used if you're on if you've got to get from A to B on a more boring stretch and you just want to save some fuel. So the rider modes we have are 4 rider modes. We have a performance mode and an eco mode, and each of those has rear ABS on and off, so 4 in total. So just a few technical highlights. I can't give you all the highlights and all the work we've done. But let's start with the sound quality of the intake, for example. We've moved the airbox up to the top of the vehicle, just behind the headstock, and the intake is very close to the rider now, so the rider gets to hear that intake noise when they're riding. In terms of mechanical refinement, we have Royal Enfield's first all aluminium barrel, so there's no steel or iron in the barrel, which means we can tighten up the clearance between the piston and the bore and reduce the piston noise. We have a hydromechanical cam chain tensioner, again just to try and refine and reduce that cam drive noise. And then to allow the rider modes, we have Royal Enfield's first drive-by-wire system, so we have an electronic throttle on this vehicle now. So performance. The rider focus here was effortless highway riding, improved overtaking, and probably most importantly just more fun when you're riding the vehicle. So what we've achieved 65% increase in peak power, 25% increase in peak torque, and 25% increase in engine speed. And we've got a transmission that's been perfectly designed all the way through and tested on-road and off-road. So just some technical highlights. How have we achieved this performance? So we've got 4 valves and we've got direct acting double overhead cam for the first time in the modern era of Royal Enfield. That improves the breathing into the engine and allows us to get the performance out of the engine. We're water cooled now, so that allows us to have a higher power density without overheating components such as the cylinder head. We've upped the compression ratio from 9.5 to 11.5 for improved thermal efficiency. We have our first forged piston, which allows us higher piston speeds and higher cylinder pressures. The all-new Himalayan now has a 6-speed gearbox, and the ratios have been perfectly designed to complement the torque character of the engine. And we have an assist and slip clutch in the engine, so similar to the twins, it provides a very light lever feel and a very smooth action. So just digging into the torque, you may have seen this comparison before, but these are the engine torque curves for the original Himalayan LS410 engine in green and the new Sherpa 450 in red. So what you can see here is we've really tried to maintain the shape of the torque curve, because that's very important to the character that everyone loves, but we've just tried to give more everywhere. So if we look at our 3000 RPM, that would be your chugging along speed, you've still got 20% extra over the original Himalayan. At 5000 RPM, that could be your cruising speed, you've got 22% extra torque available. When you're really trying to demand more from the engine, you might be making that overtake or accelerating up that pass. You've got 68% extra torque available, and you've still got an extra 1750 RPM. And that, along with the 6th gear, really improves our highway performance, makes it much less tiring. So just a very quick slide to show why we're different and what we've targeted here. So these are 3 other torque curves in blue, grey and orange of motorcycles that are currently in our segment. And this is just to explain that we are not chasing a power figure at Royal Enfield. What we are trying to do is maximise the low to medium speed torque available. And this is where a rider would spend 90% of their time. So this is what we've really tried to target with the Sherpa 450. Mass is obviously important to the rider, a lightweight feeling. So we've achieved on the Sherpa 450 engine, including cooling system, so the radiator, fan, hoses, and all fluids, we've saved over 10 kilos over the original Himalayan engine. Also now the engine is a fully stressed member of the frame, so there are no frame rails running from the front to underneath the engine, which allows the frame itself to be lighter. Just some technical highlights. We have our first forged piston and our first fully aluminium plated barrel, which saves a significant amount of mass. We've got plain bearings on the crankshaft, so the main bearings and the big end bearings are plain bearings, which are significantly lighter than their rolling element counterparts. We've got rare earth magnets in the alternator and the starter motor, which allows them to be much smaller and lighter. And we've developed in-house, along with our suppliers, much thinner wall aluminium castings and steel forgings for the internal components. So efficiency, so the rider focus is fuel economy. So what we've achieved is 28.15 kilometers per litre on the international test. But obviously real world riding is individual, depends on the individual's riding style and their routes. So what we have to help with this is we have the rider mode, we have the eco mode, which can help, and also we have visuals on the TFT dashboard now to tell the rider when to change gear for the most economic riding. So we have the drive-by-wire system. We are liquid cooled, which actually does save us fuel because we no longer have to inject extra fuel just for component protection to keep components cool. We've worked really hard on our combustion system, so we have a very high tumble intake port, and we have machined angled squish, so we get really fast and complete combustion. We have a dry sump system, or a semi-dry sump system, which scavenges oil and air from the front half of the engine, which has very high speed spinning components in it, and places it under the gearbox. So that helps with windage losses. We're not whipping up lots of oil, and actually helps with pumping losses out of the breather. For the first time at Royal Enfield, we're using DLC low friction coating on certain critical components. And the piston itself has a coating on it to work perfectly with the plated bore. So a couple of slides on vehicle integration. So what I want to get across here is this wasn't an engine that was designed in isolation or independently and then bolted into a vehicle. This engine and the vehicle have been designed all the way through in parallel to work perfectly together. So I'll try and explain some of that now. So if we just look first at the high speed riding and the mile munching journeys, we've got a very high 450 kilometer plus fuel range. The engine itself can support multiple electrical accessories. We've positioned the mass as low and as far forward in the vehicle to help with high-speed dynamics and handling. And the engine itself stiffens the frame significantly, again to help with the handling and stability. So we have a very high power 418 watt alternator in the engine. We have the dry sump, which actually allows us to move the crank very low in the vehicle. We don't have to have an oil sump underneath the crank. We've angled the cylinder. So in the original LS410 engine, you will remember that the cylinder was upright. So we've pushed the crank down and we've angled the cylinder to make use of all of the packaging space up to the front wheel, and all of this mass is now as far forward as possible. And also you'll notice that the airbox is at the top, and that's quite a light component, and that allows fuel to be lower in the vehicle. We've got a cat box here, which is quite a heavy component, but it's perfectly on bike centre line, and that carries out a significant proportion of silencing, which allows us to have a much smaller silencer at the rear of the vehicle. So finally, on vehicle integration is the off-road riding. So in terms of what we've achieved, we believe we have the ideal high torque character for off-road riding. So that torque is always available, you don't have to be in the perfect gear, and the gear ratios have been designed perfectly to complement that. The centralised mass we've just been talking about really helps with the agile low speed handling, so as soon as you're moving the bike feels so agile. Also with the semi-dry sump system we can raise the bottom of the engine right to the crank web level, which means that we can improve our ground clearance to 230mm. And also with the airbox here and the air intake very high, that can improve or does improve our wading capability. With the airbox moved, so it was between your legs on the original Himalayan, it's now here. The only thing between your legs really is the rear suspension unit, which is very narrow. So the waist of the vehicle itself is extremely narrow. So when standing, you have very narrow ergonomics and much better control of the vehicle. We're also offering component protection as standard. So on the bike as purchased, we have the sump guard, we have the radiator guard, and we have hose protection. And then we're also offering further accessories if you wanted to. So finally, really, I guess something that people may not realise, even down to the level of the silencer. If you notice, the silencer is tall but very narrow. So even in very narrow off-road trails, it's much less likely to get caught by a rock or a tree. And then finally, the technical specification. So I won't read through all of this because it's probably available, but it's our first liquid-cooled engine. It's our first double overhead cam engine. We've got 40 PS at 8,000 RPM. We've got 40 Newton meters at 5,500 RPM. The all-new Himalayan now has a 6-speed gearbox and a piston slip clutch, and it has our first ride-by-wire system on it. So thank you very much for listening. Have you got any questions for me?
Thanks, Ben. Amazing information. Yes, I have a couple of questions.
Okay.
How does a dry sump help over a wet sump? What are the advantages? Are there any disadvantages?
So I guess the disadvantages are that there are 2 oil pumps. So there is a small amount of mass and cost, I guess, a small amount of parasitic loss, but the benefits we get are much greater. So we scavenge the air and oil from the crankshaft, the ACG and the balancer shaft. So we don't have to worry about whipping up lots of oil and foaming the oil. Also, like I mentioned, the losses themselves, so windage losses, there's actually a slightly lower air pressure in the front half of the engine, and pumping losses out of the breather. So if we didn't have this segregated engine, we would be pumping out and in of the breather system, whereas actually the flow out of the breather is very smooth. We don't have that pulsing, so we don't lose that energy. And it allows the packaging that I mentioned, where we can bring the bottom of the engine much closer to the crank web.
Wow, I learned something new today. Thanks. And you had mentioned something about the timing chain tensioner. Is that something different from what we've had in the Royal Enfield?
Yes, it is. It's really only for MVH reasons, but yes, it's basically to quieten down and soften the pulses that you get in the cam drive system. So as you can imagine, the crank is not revolving at a constant speed. Throughout a cycle, it's fast and slows down. And also the cams themselves have their own torsional vibration because they are opening and closing valves every cam revolution. So the cam chain has a lot of torsional vibration to deal with, and the new hydromechanical tensioner dampens some of that out and improves the noise quality.
All right. And you had mentioned about the alternator, the wattage it puts out. That's good enough for auxiliary lights?
Yes.
Comfortably it can carry the auxiliary lights.
Yeah, absolutely.
And I think Royal Enfield, the accessories there is a plan to bring out some aux lights.
I believe there is. Yes, I'm not the expert on that, but I believe there is a plan to bring out accessory auxiliary lights. We also have the USB charger on the vehicle now. So yes, it's proofed. It's future proofed for electrical accessories.
All right, because that's one of the favorite accessories. In India, at least, I do not know anywhere else, but the first thing most of us do is fit an extra set of lights on.
Understood. Yes, yeah, and use the horn a lot.
Yeah, it's on more than it's off. Well said. Yeah, you got that one right. Okay, and the airbox. Moving it up, yes, you mentioned an advantage of a lighter component being higher up. Any other advantages of having the airbox up there right in the front?
Yeah, absolutely. So I mentioned the higher intake for wading capacity, so much less likely to drown the bike. You've got the intake noise, which personally is probably one of my favourite characteristics of the new Sherpa 450. It's quite addictive. So yeah, there's quite a few reasons there. It also just works with our architecture that we've got quite a downdraft intake port here with the injector packaged very tightly in the head, and that gives us added performance. So it just works with the angled cylinder and the whole package.
All right. Anything different in the maintenance, or is it as per modern industry standards in terms of engine maintenance, oil change, valve clearance checks?
So we are still finalising service intervals for all markets. We have finalised the Indian market only at the moment, and we do optimise them depending on market requirements and riding. So actually I think we're quite similar, if not improved. So the oil is different, it's 10W40 semi-synthetic. The oil change, oil filter and air filter are 10,000 kilometre interval. The tappet clearance is 10,000, 20,000 and then 40 and 60. So there's no longer a tappet clearance check at 500 kilometres like the other models.
Okay. Thank you, Ben.
No
Fantastic. Thank you so
Fantastic.
much.
Thank you very much.
Thanks, Ben.
No problem.
Nice meeting you.
Nice to meet you. I'm
Thanks.
glad you enjoyed it.
Thanks for the great engine. Good job.
No problem. Thank you very much.
Thanks. I hope you enjoyed this episode. Any questions, please post in the comments. I'll try and get the answers from Ben. Take care.